starting in yes. All right, in now we go to the good node, right? M605. Right, here นนทกรครับyeah that one มาอีกนะครับกิตติวัฒน์นะครับgo live มาอีกนะครับปันทัศน์นะครับไปหมดแล้วนะครับ YouTube อันนี้ก็อัดแล้วด้วยนะครับ alright so มาอีกนี้นะครับ we will start our lecture for M605 right now in good afternoon everybody welcome you to SCI33205 in มีอันไหนอีกไหมครับมีคนไหนจะเข้าอีกไหมเอ่ยมาแล้วครับปาฏิหาริย์ครับ OBS พีรทัศน์ครับรอก่อนก็ได้ครับก็พิมพ์มาได้เลยนะครับถ้าใครผมยังไม่ได้ส่งที่ YouTube ให้ใช่ป่ะมันจะมี2ช่องนะครับที่ส่งหาจากนี้แล้วมีเริ่มพิมพ์กันมาแล้วนะครับ the YouTube, right? Oh no, not this one. Oh no. Yeah. This and this. All right. ส่งลิงก์ให้นะครับ1 อันนะครับแล้วก็1 อันนี้นะครับที่ YouTube ครับถ้าคุณอยากไปดูนะครับที่ YouTube นะครับก็ส่งให้แล้วนะครับสำหรับอันนี้แชทของที่ Zoom ก็น่าจะเรียบร้อยดีครับวันนี้เราจะว่ากันเรื่องwe are going to talk about galvanometer, right? Everything is all right. We will start right now. Yeah. Galvanometer is an ancient measurements tool, okay, for most electrical engineering for engineering application with a device and so on, right? this is the actual figure ไม่รู้ผมขึ้นแล้วหรือยังครับ galvanometer นะครับ this is the actual generation, okay, the galvanometer in the first generation, that's the ancient one, in 1910, okay, it's left in the museum, moving coil galvanometer, okay, yeah, with unit pivots, okay, it means there is only one rotating, okay, yeah, one rotating point, okay, and needle, okay, there is needle and paddle created by this person in the museum in United States Kingdom, and here is the actual version you can the version that you can find nowadays on the market in an online shop. All right, and yeah, that's the thing. You can buy it by ordering from any online shop. This is the version you can find at the moment, okay, nowadays. It has two poles, the blue one and black one. Yeah, it's used to measure anything, okay, it depends on your purpose. Here is denoted by the alphabet G. All right, you can see it. It's denoted by the alphabet G in what else? Yeah, and the structure inside the galvanometer is somehow that you have scale and permanent magnet. Okay, รับวิพลครับมาอย่างเลยรับวิพลครับนี่ครับ okay, you have a plate, okay, that consists of scale, and this is the needle or the pointer, and here is the coil, all right, and here is the pivot, and there is a spring inside, okay, the spring is attached to the frame of the galvanometer, and to the axial or the shaft of the galvanometer, okay, and yeah, it's circular, it's in this shape, okay, it circulates like this. The purpose of the spring is that, okay, SP stand for spring, okay. Springs mean something that will move that object back to the previous or the former location, okay. For example, ละวิพลคืออะไรครับโอ้ยไม่ต้องแอดนะครับตอนนี้ยังไม่ต้องแอดกันดีกว่าเพราะว่าใช้316นะครับผมใช้316ธรรมดาเข้านะครับใช้316 password 851นะครับ password 851เข้าธรรมดาครับโอเคไหมครับก็เราก็ใช้ตรงนั้นไปดีกว่านะครับ alright, now we go ahead with our stuff in yeah, the structure inside the galvanometer, right? And for example, at the beginning the needle just stay here at this position, and yeah, there if there is okay, there is magnetic field lines, right, coming from the north pole to the south pole, and of course in the shaft there is the coil, okay, around the shaft, in when the current flow in through the coil, all right, there will be induced force, and that induced force will bring up to the torque, right, the two amounts of force, okay, at both ends is gonna give us the so-called torque, okay, and the torque will try to rotate this shaft, okay, and this side is attached to the needle, and when the force make the needle to be here at this location, the spring will bring it back, okay, when there is no current in this coil anymore, or at this solenoid anymore, okay. The spring will try to bring this shaft back to the previous location of the plate. All right, in core, okay, it's surrounded by coil again, and you can see here the blue one, which represent the arrows of the magnetic field line starting starting from from one side of the permanent magnet, okay, and we would realize that this is the north pole, right? Because the north pole will let the magnetic field line start from, okay, and it will reach the south pole of the magnetic field, magnetic permanent, right? And of course, there is a pointer, okay, or needle, and there is spring, right, to bring the shaft ก็คือแกน okay, เพลานะครับ shaft back to the original state, okay, which is the zero position here. This is the scale, right? And yeah, it can be number 10 or any maximum bar, okay, or points on the scale. The coil is made of soft iron, and the coil is wound around the cylindrical shaft, okay, and that has to pass through the pivoting point, okay. There will be magnetic field from the shaft also, right? That passes from the north to the south, okay. And what else? There is nothing more, right? Galvanometer is the historical name of an instrument. Yes, as I told you, it's an ancient device, okay, but it's quite useful, close to our theory that we have seen in the previous section. The most common type of the galvanometer that we are going to we will consider later is the Dasongwan, okay, Dasongwan galvanometer. I think it's the French name, right? That's the most favorite type of the galvanometer used in that generation, or even nowadays. Now there is a current, when there is a current in the coil, the magnetic field will exert the torque on the coil, right? And the torque will happen at the shaft, okay, and the force will take place, or the torque will take place here, and it's gonna deviate, okay, or rotate the needle from the original state, or from the zero position to any bar here. All right, when the angular deflection of the coil and the pointer is directly proportional to the coil current, okay, it's because of we have the torque equal BN, right? BIAN BN psi phi. All right, here, and it's not that's the case, okay. That's why if we have more torque, okay, we would have a better angle deviated from the original state, okay, the zero bar. And what else? The phi, right? Phi is the angle between that. Is the same thing, right? And if we insert more currents, we will get more torque, okay. If this one is the input, maybe you have done it in the homework, during the homework, right? The first application for the galvanometer, okay, you have the piece of device here, but we don't know yet how we could apply it to any application. What can we apply this device to, and so on, right? Well, there are two ways to use the galvanometer, and we will face with right now. The first one is to use it as the ammeter, okay. Here is the notation of the galvanometer. You have the capital G, and it can be used as the voltmeter and the ammeter. All right. Okay, there are two ways for that. Here and here, right? Yeah. as you know, the ammeter is used to measure which quantity. What do you think? คิดว่าใช้สำหรับวัดหาอะไรครับ ammeter แล้ววิพลส่งอีเมลมาไม่ทราบว่าเพื่ออะไรคือแอดเข้าไปในนั้นครับผมยังไม่สะดวกแอดตอนนี้ครับเดี๋ยวหลังจากเรียนเสร็จก่อนแล้วกันครับเพราะว่าตอนนี้วุ่นวายกับอุปกรณ์คุณหมดเลยครับyeah is there any idea about it what is the application for ammeter and as you know ampere is the unit of the current right so you may guess that ammeter is the device used to measure the current okay ammeter right ammeter here is ammeter is used to measure the current current and the next one is the voltmeter which is denoted by V okay surrounded by a circle and it's written right there okay volt meter and use it to Nuts and Cloud I don't understand ผมต้องลบอะไรใน iCloud เหรอว่าอย่างไร alright แต่ว่ามันก็ยังไม่ได้ใช้โอเคก็เราก็ลบเกือบหมดแล้วนะครับ alright okay the voltmeter is used to measure the voltage across two different points across any device okay let's say measure the voltage okay as the name suggests yep it's voltmeter and ammeter right that those are the measurement tools we could apply the galvanometer to in let's consider the first one okay when we are interested in applying the galvanometer as the ammeter right so before that you may need to know first what is the theoretical idea of the voltmeter and the ammeter right the voltmeter the ammeter first right meter okay should have zero zero resistance all right and yeah unlike voltmeter oh I'm stupid I should not write down the small letter ammeter right and voltmeter voltmeter should have okay we prefer that should have infinite resistance okay infinity value actually resistance so what is the reason behind that because if you take a look at any branch of circuit let's say is the R of interest Rm okay and you would like to know what the current in this branch is so it's let's say it's I right in you would like to measure the current passing through this resistor, and how could we do that? Okay, and in the same way, if we in the same way, if we have voltmeter and we would like to measure the voltage across these two things, so you should, okay, there is current, right? There is current flowing like this, and yeah, it's Rm, okay, the measurement, the resistance of anything that you would like to measure. And in order to measure the voltage across this, first we would like to measure the current across this branch, okay, ammeter first, and we will go later to the voltmeter. What is the way, okay, how could we measure the current through this branch, okay, how much charge flowing through this resistor นะครับลองดูว่ามันควรจะเป็นค่าอะไรนะครับเพื่อการต่อยังไงนะครับเพื่อว่าจะวัดกระแสผ่านตรงนี้นะครับ alright any idea about thatนะครับมันไม่ค่อยเป็นฟีดแบ็กเลยนะไม่ค่อยมี2ทางครับก็ผมก็ต้องอธิบายไปokay, the way to measure the current is that you just cut this branch, okay, cut it and leave the current the current measure device, okay, which is the ammeter, okay, let's say it's A here, okay, it's connected there, right? Like that, and yeah, ammeter should be connected, okay, ammeter has